So I decided that I would show what happens with the sun, and I think it may solve some interesting problems. I'll show that in this video. And I just want to revisit something before we do that, and that is the fact that there is a lot of water in our atmosphere. I went to a few websites. I just did a Google how much water is in the atmosphere, and this is the USGS website, usgs.gov, Science for a Changing World. The USGS Water Science School talks about there is always water in the atmosphere. Clouds are, of course, the most visible manifestation of atmospheric water, but even clean air contains water, water in particles that are too small to be seen. One estimate of the volume of water in the atmosphere at any one time is about 3,100 cubic miles, or 12,900 cubic kilometers. And it goes on to say that if all the water that's in the atmosphere were to rain down at once, it would cover the globe to a depth of about 1 inch. And this is confirmed on a number of websites, but I'll just show you one more just for the sake of argument here. This is the Y Files, the science behind the news. They have an article, How Much Water is in the Atmosphere? It says, at any moment, the atmosphere contains an astounding 37.5 million billion gallons of water in the invisible vapor phase. This is enough water to cover the entire Earth, land and ocean, with 1 inch of rain. And, of course, goes on to talk about that as well. So, yeah, there's a lot of water in the atmosphere. I think we all kind of just know that, but I don't think we've ever really thought about what that means. And so I was thinking about that in the previous video, and so I'm going to go ahead and play just sort of some highlights from that previous video to set the stage for what I think is going on with the sun and the moon also. Here we go. But I'm thinking if the atmosphere, especially over water, is made up of zillions and zillions of tiny convex drops of water, then collectively perhaps they all combine to make one big convex lens, in which case it would act like a magnifying glass. Okay, so with that in mind, let's look up some websites dealing with the refraction of light. You might see a graphic something like this, showing light bending downward, just like the weatherman guy said. And here's your typical graphic showing how light rays entering some sort of medium, like in this case water, refraction causes the light to bend downward. Now we've all seen pictures of, a pencil or something in a glass of water, and how not only does refraction bend the image downward, it also magnifies it. I'm going to say that again. Water causes refraction, bending the image downward, and magnifies it.
The science is the same of that of a lens. Here's a simple example.
So if you're looking at Chicago here, just maybe now you can just see the top of the Sears Tower, and if our simulated temperature inversion moves into place, hopefully now you can see pretty much all of Chicago,
see all the lower buildings,
including what's at ground level.
So the atmosphere really is acting like a lens.
Yes.
Here's what I came up with. I've got my magnifying sheet frame, and I created a little stand to paste the sun on it and keep it the same height over the flat surface of a table. So the sun is always going to be parallel with the surface. And check this out. All right, here's the first test of a sun moving over a flat surface, and with no atmospheric magnification, it does what we might expect it would. It gets smaller as it goes away from us. All right, now let's see what happens when we add in our atmospheric magnification. Again, water and refraction. Water causes magnification and refraction, right? So let's bring the sun back. Oh, check this out. Refraction bends the light downward. It made the sun set on a parallel surface. As it was moving parallel, the same height, the whole way over a flat surface, the refraction caused the sun to set. Not only that, well, let's bring in the beginning of that little test, and we see that it maintained pretty much the same size, too. Pretty close. And of course, that's because as it's moving away, the magnification is still taking place. And so even though the sun's further away than it was in the beginning of the test, the magnification basically preserved the same size, and the refraction made it set. Now, I'm just going to put forward a crazy idea for you to think about. And that is, if Rob Skiba could figure this out, I'm just going to go out on a limb here. I think it's quite possible that the creator of the cosmos could have figured out the same thing and engineered our beautiful sunsets, thanks to all that water he placed in our atmosphere. Just something to think about. Thanks so much for watching. I hope you enjoyed this video presentation. If you did, please subscribe to my YouTube channel, like the video, and share it on your favorite social media sites. There's a lot more to come, so stay tuned and we'll see you back next time.